Our research at Columbia University College of Dental Medicine has been dedicated for in situ regeneration for musculoskeletal and craniofacial tissues by stimulating body's own stem cells, and start helping lots of patients suffering from knee meniscus, tendon, and TMD disc problems.
And with the help of the bioplotter from the Envision Tech, we can precisely control both the outer and the inner geometry of the avascular meniscus, tendon, and bone-to-tendon tissue scaffold that we are printing.
Our lab has been using the bioplotter more than 10 years, starting with the second generation. So our technology developed through the bioplotter now at the stage of the large preclinical animal studies.
We took a MRI scan of sheep, and then we printed the sheep-specific meniscus, and we implanted those 3D printed scaffolds to the specific sheep. And after 6 months, we harvested those scaffolds and saw very promising outcome of the fibrocartilaginous tissue regeneration from these scaffolds.
We are also trying to develop a scaffold that can deliver growth factors for tissue regeneration. 1 out of every 12 person in the USA are facing temporomandibular disorder, and the consequence is severe. You will feel severe pain. Eventually, you will have compromised vision, compromised hearing. The beauty of the 3D printing is that you can mimic whatever you want, any structure. We can make a scaffold that is very close to the TMJ disc. So that's why we are working with PCL, we are working with hydrogels. The idea is that PCL will give us mechanical strength and hydrogel will provide us bioactivity or targeted growth factors to solve this problem. I like this machine. It's flexible, and I use the exact same machine in the University of Saskatchewan while I was doing my PhD over there. I've been working with this machine for 8 years.
In this bioplotter, we have a platform that we can control the temperature. So we can raise or maybe lower the temperature depending on the material we are printing.
In accuracy and the functionality is the key compared to the all other 3D printers.
In the micrometer range level, you can have the precise orientation of the inner tissue architecture and also the outer shape of the tissue.
And also there are many patients suffering from damaged tissue, medical issues. So our research aims to provide some hope for them to have a regenerative tissue for their damaged body.